Now hopefully from last week's lecture you remember that AutoCAD lines and arcs and circles and other geometry, they're not created by filling in little squares on the screen with color. Those are raster graphics. AutoCAD uses vector graphics. So a line in AutoCAD is not a bunch of little squares of white from that point to that point. A line in AutoCAD is actually a mathematical expression based on the start point of the line and the end point of the line. And then there's some descriptive properties that also tell us how fat the line is and several other characteristics that it might have. Okay, so we want to use AutoCAD at what it's best at, and it's best as a fancy, high-powered graphic calculator. Not graphing calculator, graphic calculator. It does millions of computations very quickly, and it shows you the results of that on the screen. And that's what these drawings are. They're mathematical properties and expressions expressed graphically. Okay, and the way AutoCAD does this is it keeps track of where all these start points and end points are in its database, and it uses coordinates to do that. Now, if you turned on all of your tools on the status bar, at the very end, the last tool is called the coordinate display. And what I want you to see is as you move your cursor around the screen, do you notice how the coordinates are changing? You see, AutoCAD is looking at the cursor and it's telling you precisely where the cursor is at any given point. And in fact, when you click, it's recording that point as the start point. And then as we move away to our second point and click, it's recording that point as the end point. All right, so that's what AutoCAD does. It tracks coordinates in space. So let's have a discussion about that. AutoCAD uses a system of coordinates called the Cartesian coordinate system. So the Cartesian coordinate system is simply a tool that you use to find out where points in space are located. It was developed by this guy here. He wasn't a slouch. He was a philosopher and had a very orderly, logical mind, and he thought, man, there must be a system to logically describe where things are in space, and he came up with a system that involves a number line, and it's called the Cartesian coordinate system. So we've all seen a number line. This is kind of a special number line, though, because it's made up of three number lines. There's an x-axis, there's a y-axis, and there's even a z-axis. We don't see that on our screen, though, because the z-axis is pointing up toward us. And the intersection of all these axes is a point called 0. Now, don't let this scare you away, okay? Because this is nothing hard. Look, Battleship. If you've ever played Battleship, Battleship is coordinates, right? You tell me which column and which row, and I go to see if my ship is there. And if it is, well, then you score a hit. And if it's not, you score a miss. Old maps, like this one, have columns and rows. And if I tell you I live in a town that's in 9D, well, you would go over to column 9, and you go down to row D, and you would know I live somewhere around there. You see, again, this is coordinates, right? Where is it in this direction? How far over is it in that direction? Even GIS and GPS and Google Earth and all these mapping systems we see online, they use a similar system, right, to locate where we are. Coordinates. So there are 5 coordinate systems that we're going to discuss. The first one is called absolute. The second one is called relative. The third one is called polar. And then there's 2 more, but you know, those last 2, they are 3D coordinate systems. We're not going to use them, so we're going to just forget about them. Okay, we're going to talk about the first 3 in our class. Okay, so what is this absolute coordinate system? Well, it works like this. Any point in space is going to have an address, and that address is described by 2 numbers. The left to right location goes along this axis. This is called the x-axis. The bottom to top location, the up and down location if you want to think about it along your screen, it's called the y-axis. So this point here is point 2, 1. See, from the starting point, from 0, it is 2 inches over. It is 1 inch up, point 2, 1. Now this point here is 4 inches over in the x-axis and 2 inches up in the y-axis. So this point is 4, 2. Point over here, 1 inch over in the x, 3 inches up in the y, it is point 1, 3. So the deal is any point can be used as a start point or an end point for a line or an arc. It could be the center point for a circle. And we can tell AutoCAD we want things in specific places without counting little squares on the grid by specifying the coordinate we'd like the geometry to start at. Okay, so the overall idea is you can describe any point in space by its relation to where the starting point is, that 0, 0 starting point. As long as we follow the format x, y, AutoCAD will know what you're talking about. Numbers move up as we go to the right on the number line. Numbers go down as we move to the left. Numbers also increase in the y-axis as we go up, and they will go down if we decrease. Okay, so here we see our 4 quadrants. We are starting at 0, 0, and we're going to be drawing out here. So here's the x-axis getting larger as we go to the right. Here's the y-axis getting higher values as we go up. Point 2, 3, 2 inches in the x, 3 inches in the y. And that's the intersection of those two locations. Alright, so what we want to do is we want to take this and we want to be able to apply this to AutoCAD. So we're going to click on Start Drawing, or you can click at the end of the tabs at the top of the screen here, the little plus sign that'll also give you a new drawing. Want a nice clean fresh drawing to work in, and let's go find that XY thing. So what is this? This is called the origin. It's where the x-axis, which is the red line, meets the y-axis, which is the green line. And you can even see the x and the y right there on the screen. Right? The intersection of the two things is called the origin. Its address is 0, 0. And when we're drawing, if we tell AutoCAD, hey, I want a line, and if it says, where do you want to start, you type in 0, 0, and hit enter. Well, now you're anchored exactly, precisely, perfectly to the origin. Right? And if we tell AutoCAD, hey, I want to go 1 inch to the right, well, we can do that. We can say, go over 1 to the right, 1, 0. See, I want to go 1 to the right, but I don't want to go up any. Now that's 1 to the right. How about the point up here, 1 inch up from there? Right? That would be 1 inch over and 1 inch up. So I'm going to type in 0.11. And it went 1 inch over, 1 inch up. This point over here, this point's going to be 0, 1. 0 in the x-axis, 1 in the y-axis. And there it is. And then we'll go back to 0, 0. That is our origin. Okay, so I didn't use the grid, and I didn't click or count little squares with snap mode. I just simply typed in the locations I wanted to go to. I told AutoCAD, hey, give me a line. And then it said, what's your first point, cowboy? And I said 0, 0. And then it said, what's your next point? Well, that's 1, 0. What's your next point? 1, 1. Then 0, 1. And then 0, 0. So why don't you try to do that? And let's see if you can draw our little 1 inch square here.